Hi, this is day 2 of section 4.5. We've been taking polynomial functions in standard form and factoring them and to put them in factored form and then find the zeros. Today we're going to do this by grouping. But before we do that, we're going to practice factoring just binomials. This is one step of factoring by grouping. So if we're looking at this is binomial, there's two terms. This is different than a trinomial when you usually have two parentheses. So here you're looking for the GCF, the greatest common factor. So we're looking at the two terms. So I have 3x squared and 6x. What number is a factor of both? Well, 3, right? So I'm going to factor that out. And I have x squared and x. So I can factor out an x. So dividing it, because that's what really factoring is, it is dividing. 3 goes into 3 one time, x goes into x squared x. 3x goes into 6x 2 times. All right. Now if you take this and multiply it out, right, and distribute 3x times x, you get 3x squared. And 3x times 2 is 6x. So multiply it out. If it's correct, it should get the expression you started with. All right, so let's do the next one. So I have 12 and 4, so 2 can go into both. But is that the biggest, the greatest factor? So let's look again. I think 4 can go into both. Now before we do that, there's this rule. If there's a negative in front, you have to factor it out. You just do, and I'll explain why in a moment. That will change the sign here as well. So negative 4 goes into negative 12 positive 3 times with the m. Negative 4 goes into 4 negative 1 time, right? 4 divided by negative 4 is negative 1. Now the reason why we want this term to be positive, because when we're grouping, it's weird to have that negative in front. So we want it always to be positive. All right, so let's group. Just an expression before we do polynomial functions. And it's called grouping for several reasons. One, because we group. So you're going to group these first two, and you're going to group those two. Now we've already done that. This is the same as number 1. So here we're looking at this. I'm going to take out a 2 and divide, and we get that. What do we notice? Well, it looks like these are the same. Yes, and they must be the same. To group factor by grouping, those factors must be identical. If they are not, then either 1, you factored wrong, or 2, you can't factor by grouping. And exactly the same, that includes all the signs too. So again, they must be the same, and that will help you when you try to factor by grouping. So these in front, guess what? You're going to group them into 1 parentheses. Now this is a really important part that students often forget and get confused about. So do you see the x plus 2? You're going to make it into 1 x plus 2. Not 2, just 1. We push them all together. It gets rolled in. So when you see 2 of them, students will actually say, Miss Mendez, what happened to the other one? It gets all pushed inside. Because, remember, we're dividing. So what this is, if you multiply these terms out, you will get this. Okay. So let's actually get to our polynomial functions. So it says to rewrite in factored form and find the zeros. So I'm going to do this by grouping. It's not always self-evident in grouping, so sometimes you have to start. But this one, I can see there's a 1 and a 4 and a 1 and a 4. So that might be a clue for this one that is definitely I can group by factoring. So in common, I have x squared. And then I have x minus 4. And then over here, I have that negative. What's the rule? Factor that out. Now, there's nothing else in common. So we're going to do a negative 1. So negative x divided by negative 1 is positive. And 4 divided by -1 is -4. Again, do we see that they're identical? And that's what we wanted. So we know we're doing it right. Okay, so we're going to group the ones in front. Right, once we get to here, we're going to ask ourselves, can I factor any more of those? And when you factor, they have to be rational. So if I'm looking at that looks fine. I can factor that. I have x plus 1 and x minus 1, and then x minus 4. So now that's completely factored, and I can find the zeros from here. Okay, excellent. All right, so let's do the next one. So I'm grouping again. So here I'm looking, I have what's in common. So no common factor other than 1 with 3 and 7. And then I have x squared. So I'm going to have 3x minus 7. Okay, now here's the thing. Because I know they have to be identical, this is how it can help you. If it's 3x minus 7, you're sure you factor that properly. Then this must be 3x minus 7 as well. So 7 goes into 28 4 times. 3 goes into 12 4 times. So it is 4. And does it have to be minus? Yes, because there's that negative again, so I factored it out. And 28 divided by -4 is -7, so we've checked. So we're going to do the front. We're going to group those together. We're going to write only one 3x minus 7. We're going to look and say, okay, this is a squared, my bad. Can I factor any more? Yes. You always check the squared if you can factor more, and I can. It's 2x minus 2, 3x minus 7. Okay, so this is factored. X equals -2, x. Okay, so there's a shortcut for this one. So this, if you don't know the shortcut, you would just write this equals 0, and then you would solve it and divide. For those who know the shortcut, you can just see it, and hopefully those who don't, you might be able to see a pattern as we continue throughout this lesson. Next. All right. So we're going to rewrite each in factored form and find all the zeros. All right. So group. Right, I have a 4 and a 12, so 4 can go into both, and then x squared. That's x squared goes into 12x squared 3 times. Okay, and then this one I have 9 and 27. That's going to, and the negative is for both of them. So I'm going to pull out a -9. That's going to make an x plus 3. Again, we knew that already from here. Right? Okay. Then we're going to group in front. Okay, write it once. Okay, look at this. Can I factor that? So maybe you may not think so, but are they perfect squares? So the answer is yes. We can if they're perfect squares. What's the factors of 2x squared? 2x and 2x. What's the factors of 9? 3 and 3. Because there's only 2 of them and it's a minus, it's plus and minus. Okay, this one I'm going to do the shortcut, and for those who don't know the shortcut, maybe you'll see the pattern. So it's plus, so it's going to be x equals minus 3 over 2. This one is 3 over 2 positive, and this is x equals -3. Okay. Last one, grouping. Okay, so I have a 2 and a 12, so that's 2x squared. It's x plus 6. Okay, I know it's x plus 6. And it must be a 5. Negative, because there's negative and negative. So I'm going to group the ones in front. All right, now when we look at this, This is not a perfect square, and this is not a perfect square. That tells me then it's going to be an irrational answer. So I can't do what we did or for like number 7. So I'm going to leave this. This is actually in factored form. We saw that when we did long division. There are some terms that you couldn't factor. This is one of them. So we know this is -6. How do you find that? Well, just like before, we're going to set it equal to 0. And we're just going to solve it. Going to divide. Now, once you get to here, you're going to be like with Miss Mendoza. It's not perfect square. I know. Can I have a square root on the bottom? No. So I'm going to multiply square root of 2 to the top and bottom. So it's going to equal plus or minus square root of 5 times square root of 2 is square root of 10. Root 2 times root 2 is square root of 4, which is 2. No, I cannot cancel out the 2 in the root 10 because it's not a positive 2. Right? It's actually the square root of 2 inside, not just a nice integer of 2. So that is also 2 answers because of the plus and the minus. So those are our 3 roots. All right? All right. Hope you enjoyed that. Bye.